Hello from New Zealand. I'm Morrison from Aalborg University in Denmark. My team at Aalborg has been responsible for tactile and audio technologies for CultAR, and the work on the glove is happening from University of Helsinki. We're specifically looking at wearable technology and, where possible, soft computing. When we're looking at the wearable market, we've seen recently a huge explosion in smart wearables, and the fitness marketplace is rife. There's wearable technologies that track and respond to your physiological data. We have smart bionic bras, smart shirts, connected toothbrushes, glasses, lots of variations there, gloves, smart watches, intelligent jewellery, wristbands, shoes, lots of work there with navigation, vests, alert pendants, caps and headbands, lots of responsive clothing happening. Most of those communication technologies use the mobile phone as proxy communication, and it also as a visualization manager. What we're seeing with this technology leap is huge leaps in sensor design and new generation integrated circuits and development boards. As well as that, we see advances in textile cabling, conductive elastics, textile connectors and sensors, which means we can integrate smart fabrics and textiles with flexible and stretchable electronics. Some of the most sophisticated on the way, soon to emerge, include monitoring of continuous blood glucose levels, pulse, blood pressure, heart health, nervous system measuring, and kidney function with alerts and triggers, integrating with peripheral sensors. Of course, managing that type of data has also challenges. Core to these advancements are interdisciplinary teams coming from fields such as software design, electronic design, manufacture and healthcare. And wearable technologies that add stress level readings and integrate fall detection and alarm functions expand that market beyond fitness to include assistive technologies. And we see that a priority for our work that we're doing is to activate, guide and warn the participants while they're mobile in part of the environment. Of course, our users are not necessarily disabled or in need of rehabilitation, but these are also still potential users with the CultAR app, even in this instance. So coming back to what we've created in CultAR, the work we've done with both the vest and the glove show huge potential for real use and commercialisation, both within the scopes of this project and from also how they can be used outside the project and beyond. So when you're designing for the body, there are many factors to take into consideration: form factor, robustness, long-term wear, hygiene, comfort, accuracy, mobility, huge range of body shapes and sizes, as well as factors such as placement, location, spacing, number and types of tactors and sensors, arrangement, frequency, tempo, sequencing, overlap, durations, to get good, to build and develop good vibrotactile patterns, as well as the connection methods, and these all have an impact on the design of multiple factors that impact the design. The glove is in its third iteration, now has 3 actuator placements on the fingers with haptic patterns that are short bursts of 100 milliseconds followed by a pause of 400 milliseconds, and this generates navigational guidance and allows for pointing at a target. So users can then either accept or reject the information by bending the index or thumb finger. And this is all set in an extremely flexible textile, and it gives the actuators better contact with the skin and to comfortably fit various hand sizes. So it proves very useful for navigation and interaction. A lot of the research happening with vibrotactile works with ensuring that users can determine where each tactor is individually felt. But in the patterns we're developing for the vest, we deliberately are overlapping transitions between individual actuators to enable a smooth flowing sensation. So what we're looking at is the effect, emulating the effect of natural touch on the body. We've developed a range of vibrotactile patterns in the vest to induce 5 sensation types: calming, feel good, activation, navigation such as full body turning, and warning to guide people when to stop. So the calming and feel-good patterns were relatively straightforward, but recently our results have shown that we can alter the ratio between overlap and duration in order to cause calming and activating sensations using the same location. So that's been an interesting breakthrough there. And we've seen firsthand how much people are surprised when they go from seeing the vest in demonstration to actually experiencing it, thinking that it would be a similar sensation all over the body, and realizing how different it is, having different sensations at different speeds, etc., on various parts of the body, or the same part of the body. With up and down the back, for example, can be either calming or activating. We can see there are many commercialization opportunities, particularly both within navigation in this project and also in the assistive technologies and rehabilitation fields. There's lots of 3D audio solutions out there, so as much as we can, we've integrated the best of those solutions to work with the CultAR app to assist with information on points of interest as people navigate through the city. So the 3D audio adds features such as degradation of sound over a distance, a change in frequency as a result of motion, and material densities. So people can get the titles and descriptions of points of interest when they're within a certain range, but whilst they're coming towards that, they have beacons indicating in 3D the proximity coming from the direction that the point of interest is located in. So that's a short synopsis of what we've been doing. I'm really looking forward to seeing you all in Padua on the 10th of December, and we can give you a hands-on experience of what we've created in CultAR, so please get ready to wear the wearables. Okay, bye-bye.